So whatever we're talking about,
Research chapter here.
it's time to get out our chapter 3 notes and finish up the last problem. Very last problem. Andrew contributes $50 a month into the fund that earns, wow, 15.5% interest. What is the value of his investment after 20 years? So, the things that need to pop off the page at you are, he contributes $50 per month. That means he's making repeated payments, right? So that's going to be the FV or the PV formulas, because he's making more than one payment. So then you got to decide, okay, is he saving for the future or is he paying off an existing loan? Well, it's pretty obvious. We're looking for the value in 20 years, right? Isn't that future? Aren't we saving for the future? So we're going to use our FV formula, which I will give you. It's there in your notes. FV is R1 plus I to the nth minus 1 over I. Okay, there it is. So now for the last problem, which is number 15. The payment is $50. Remember, R stands for the payment in both formulas. R is the payment. This is the tricky I, though. You don't just put in 0.155. We have to divide it by 12 because the payments are monthly. So it's 0.155 divided by 12. That's my I. And we got a minus 1, and we have the same I on the bottom. Now, N in this formula, N is the total number of payments, over the life of the problem. So he's making monthly payments for 20 years. So what's that exponent going to be? 20 times 12, 240. And in this formula, that's positive. You want to pay attention to that. In the other formula, that your exponent is negative, but this one's positive. All right, let's everybody type it in and see if we can all come up with the right answer. You have to be in the habit of bringing your calculator every day. When you get an answer, feel free to share it.
What is it? $1,607.35.
Did you forget to multiply by 50?
Oh yeah, I did.
Yeah. Remember, Jacob and everybody else, when you're writing down your answer, think if it makes sense. If you're putting $50 a month in for 20 years, you're probably going to have more than $1,000, right, in your account. Who got a different answer? What'd you get, Ellen? Yeah. So $80,367.73. All right, that wraps it up, folks. Now it is time to start reviewing. I turn that on right there. Okay, so let's see. Which one shall we start with? We have so many review sheets. It's amazing. Let's start with the one called Practice Test Chapter 3. So so one of your papers is called Practice Test Chapter 3. Let's start with that one. We review today. We'll review one more, our next class, and then the next one after that's the test. Okay? So here we go. Notice that some of the problems are marked with asterisks, and that means they are calculator problems. This test will be in 2 pieces. Here I kind of got things mixed up a little bit, and they won't be that way on the test. It'll be in 2 separate pieces. So let's go through and do all the no calculator problems first, and then we'll get out our calculator and move on. Yes?
Can I find this on Schoology?
Everything's on Schoology. Okay. Chapter 3, extra practice and review. All right, so here we go. Number 1, A. All right, got to solve it. Ideas? Step 1?
Divide by 2.
Absolutely, divide by 2. So log base 3, x minus 2 equals 2. Then, there's not much room on here. You might want to be doing this on a separate sheet of paper. Or if you want to do it, if it's easier for you, given everything you've been through, to do it in Notability on your iPad, I'm fine with that. Whatever works for you. But you're really not going to be able to squeeze it all on here. What now? Loop de loop, that's right. So 3 squared equals x minus 2. 9 is x minus 2, so it looks like x equals 11. Right? That's easy. Everybody gets that one right. Okay. What about B? Log base 7 of the 4 through to 49 equals x. Step 1. We're going to do exactly what you did here. It's exactly the same format. So we're going to loop-de-loo it. 7 to the x equals a 4 through to 49. Now what? Is 49 at all special?
Yeah, you have to make the base the same.
You gotta make the basis the same as a 49 7 squared. Now what about a radical? What does the 4th root mean? To the 1/4. So I have 7 to the x equals 49 to the 1/4. But 49 is the same as 7 squared. And once we have the bases the same, we can set the exponents equal. So, double exponent always means multiply. So we're going to multiply those together and get 2/4 or 1/2. So x equals 1/2. Remember, anytime you have an exponent next to an exponent, it's a multiply. All right, C, I'm not even going to take the time to write it down. What's the answer to C? 5. That's one of your properties, folks. That's 5. That's 5. D, a little more involved here. What do you think we ought to do to start this thing? Can we drop the LNs out? We had LNs everywhere. Can I just drop them out? No! When can you drop them out? When there's 1 on each side, right? If it's log x equals log y, x equals y. But you cannot drop the logarithms if you have this many floating around. In fact, I hope I made a big deal to you that you can't have more than 1 logarithm on a side. So you can't do anything until you put these together. So when these go together, they're going to go together as 1 ln, ln what? What's gonna be in that parentheses for this side right here? 38. Be brave, you know it. If logarithms are added, the numbers are multiplied, sure. Over here, I'm gonna do the same thing. I'm gonna put these together, but it's not gonna be x times 2. It's going to be x divided by 2. And now, I have ln equals ln, so now I can say 38 equals x over 2, and x equals, what is that? 76. Is everybody okay with that? B's another one I'm not writing down. What's the answer? 0.7. Remember, when an ln and an e touch each other, God. The next one I need to write down. Take a look at the next. Take a look at problem F. We just talked about something similar to this. This one's a little different, but it starts the same way. See this right here, guys? Red flag. Can't have it. You've got to, before you do anything else, you've got to put those two together. So how are they going to go together? What's it going to look like inside that parentheses? X minus 3 over 2. Yep, Josh?
Oh, yeah.
That's what you were going to say. Thank you. X minus 3 over 2. We're kind of all out of that raising the hand thing. We're used to shouting into the Zoom. Sorry to overlook you. Do you know the next step?
Multiply the 2 or divide the log over.
Now, I can't divide the log over. This is one piece. These are hooked together. I gotta loop and loop. If there's a logarithm on both sides, you drop them out. But if there's only one logarithm, you're gonna have to loop the loop to get rid of it. So 8 to the first equals x minus 3 over 2. Now I'll multiply by 2. So 16 equals x minus 3, and x equals 19. All right, a couple more in this section. Let's see. Log base x of 2 equals 1/3. Well, we just talked about it. Isn't that exactly what we had right here?
Yeah.
So we're going to loop through it. And it's going to say x to the 1/3 equals 2. Now remember, well, many of you probably know what the answer is right now, but if you don't know the answer, remember a fractional exponent is a radical. So this is saying the cube root of x equals 2. How do we solve something like that? What do we need to do? Cube both sides. So certainly you don't have to show all this work. Certainly when you got to this step right here, you could tell me x is 8 because the cube root of 8 is 2. Remember, this is no calculator, so you're not going to get wacky things. It's going to be your normal numbers. All right, one more in this section. ln 4th root of e to the 7th equals x. Now, this problem has an ln and an e in it, right? If they're touching each other, I can get rid of it, but there's a radical sign in the way. So what might I do with that 4th root? Make it a fraction. Oh, exponent, a fractional exponent. So ln e to the 7th to the 1/4. Double exponent, we have e to the 7th to the 1/4. So that's ln e to the 7/4. So the answer is 7/4. Your ln and your e will always cancel if they are actually touching each other. If there's anything in the way, they don't cancel. Okay, that was section 1. Anybody have an issue about anything that we did there? We went through those kind of fast. Anybody have a question about one of those problems? Okay. Number 2 says, write the equation of the exponential. So when I say the word exponential, you should immediately think this. That's what an exponential is. You've been given 2 points. Who remembers? This is like the very first section of the chapter. Who remembers?
So you have to like plug in 0 and 4 in order to kind of figure out that A equals 4, and then you go off from there.
Okay, so he's right. So you got a y and an x. You're finding a and b. So you're just going to plug in your points one at a time. And we always start with the 0 first, the point that's got the 0 first. And we've done so many of these that we recognize that when we put a 0 here, that goes away. So a just ends up being 4. Remember, the y-intercept is always your initial value. And your initial value is always a. So this is y equals 4b to the x. Now, to find b, you actually do have to plug in, like Jacob said. So we have 16/9 equals 4b squared. Right? Now, you do it however it works for you, but remember, there's no calculator. So when you divide by 4, you're going to have a fraction over here divided by 4. So it might be easier to, instead of thinking of it as dividing by 4, think of it as multiplying by 1/4. So b squared equals, you can either say 16 over 36, or you can actually reduce that, right? 4/9. And then we'll square root. So b equals 2/3. And our final answer is y equals 4 times 2/3 to the x. All right. Oh, now we got a blast from the past. We got state the domain, range, and asymptotes of these, and I think that would be much easier done with a sketch, so I'm going to go ahead and graph both of them. These are examples of my BFFs. Remember when we learned all that BFF stuff? Well, the next chapter is going to be the sine and cosine. You just can't forget them. You got to remember your BFFs. Oh, did I forget one? Oh, B has a star next to it, so I'm going to do all the calculator problems at once. So we'll do 3 and 4, and then we'll jump back and do B. Okay? Because on the test, everything without a calculator will be in one chunk. All right, so I'm going to remind myself real quick of what the logarithmic function looks like. This is the logarithmic function. You still have your BFF flashcards? This is the logarithmic function. Okay? Now, what does putting an x minus 2 do to that picture? Who remembers what that does? Moves it to the right, 2. So this picture, the new picture, everything's gonna move to the right two. So the asymptote is now gonna be at 2. That point will now be at 3, 0. You weren't asked for it, but there it is. So that's a picture of that curve. So your job is to list the domain, range, and asymptotes for this picture. Well, we already did the asymptote. What's the domain? Where are my x's? Bigger than 2. So my x's are 2 comma infinity. That's exactly right. That's your domain. X is bigger than 2. What's my range? All reals. So my range is negative infinity to infinity. All the way up and down. Arrows going all the way up, arrows going all the way down. Okay? Now, this one is a version of the exponential. So I'm going to draw my basic exponential. This is my just regular old exponential. Right there it is. What does that minus 4 on the end do to it? Down 4. So that means the whole thing's going to drop down 4. 1, 2, 3, 4. So now my asymptote is y equals negative 4. And that point is now 0, negative 3. And my picture looks like this. So this is the one now I'm answering the questions about. The asymptote is at negative 4. Y equals negative 4. What's my domain? What are my x's here? All reals. So your domain is negative infinity to infinity, all reals. What's my range? What are my y's? Greater than negative 4, so negative 4 to infinity. Yep, perfect. So at first I could see some panic in your eyes, but now that we've talked about it, hopefully that's coming back to you a little bit. This whole chapter has been about logarithms and exponentials, your two of your BFFs. All right, one more, no calculator. Number 4, consider y equals 3 to the negative x. Y equals 3 to the negative x. What does a negative exponent mean? 1 over, flip, 1 over. So another way to write this equation would be 1/3 to the x. So when it says, what is another way to write the equation? Right there. That's another way. Is it a growth or decay? Ah, perfect. Decay. How did you know that? You're right. You are right on target. How did you know that when you said it? The base is less than 1, right? This is your exponential, and the base is less than 1. So that means your problem, instead of looking like this, it looks like this. That's a decay. Yep, perfect. And then it says sketch by plotting some points. You don't need, if you need to plot points, go ahead and plot points, but if you just know that's what it looks like, that's okay. If you needed to plot points, what that means is set up a T-chart, pick some X values, figure out the Y's, and then plot those points. All right, is that it? Yes, that's it for no calculator. Does anybody have a question about that? Okay, then let's go back. We still have to do 2B. We'll start in with all the calculator problems. So we'll start with 2B. And we actually did one of these in our quick reviews we were doing in class. We want to write a logistic function. The initial value is 6. The limit to growth is 18. And is that 2 comma 144/17? Remember, I'm old, so you need to help me with this little writing. Okay, all right, here we go. So, logistic. We know the format is going to be something over 1 plus BC to the x. That's what our logistic format is. Who remembers what we can,
18?
what?
Is A 18?
A is 18, absolutely, because that's your limit to growth, right? So now we have y equals 18 over 1 plus bc to the x. So I've used that information. All right? Who remembers what happens next? We talked about it with the exponential. Remember, your initial value is always your y-intercept. So you plug that point in. So remember, the initial value and the y-intercept are exactly the same thing. So if you're given a number for the initial value, that's the y-coordinate at 0 comma that number. So if I put 6 in for y and 0 in for x, what happens to this? So I have 6 equal to 18 over 1 plus b. Right? So then I will, so 6 plus 6b equals 18. 6b equals 12. I got b equals 2. Is that what you got? So now my equation, doing it one step at a time, looks like y equals 18 over 1 plus 2 c to the x. And now's where the fun begins, because now we get to plug that in, right? So here we go, 144/17 equals 18 over 1 plus 2c squared. Cross multiply. Remember, you are allowed to use a calculator. So 144 plus 288c squared equals 17 times 18, 306. Subtract 144. So 288c squared equals 162. And c squared equals 162 over 288. Which is 9/16. Remember, to reduce your fraction, you can go ahead and type that in, and then hit math, enter, and it will give you 9/16. So c equals the square root of that, which is 3/4. So my answer is 18 over 1 plus 2 times 3/4 to the x. Sign out. Let's try not to make this a habit. We got important stuff we're doing here. All right, everybody okay with that? All right, so that was 2b. So now I'm jumping down to 5. This says evaluate the log base 7 of 19. Okay? Help me out here. Who remembers? There's a short way and a long way to do this. Anybody remember the short way? Rory.
Don't you do log 19 divided by log 7?
That's exactly what you do. Log 19 divided by log 7. So if you want to save yourself time, you'll remember the change of base formula. That's what it's called. It's not really a formula. It's the log of the big number over the log of the little number. The little number goes on the bottom. The bottom number goes on the bottom. Top number, bottom number. And you just type it into your calculator. The only way you could mess this up is if you forgot to close your parentheses. So make sure when you do log 19, you close your parentheses and then divide it by log 7. So I don't know if I gave you any rounding directions. I didn't. There'll be some on the test. I'll just do 1.5131. Good job, Rory. Good job. All right, number 6. How long will it take to triple an investment if the interest rate is 1.8% compounded monthly? Now, when you read that problem, what's the first decision you have to make?
Growth or decay?
Well, what formula am I going to use, right? And I hope it's a money problem, Jacob. I hope they're all growth. But yeah, I need to decide what formula I'm going to use. And you have 4. You have 4. There's more than that if you've looked at your book. There's more than that, but these 4 will solve all of our problems. So which one is it going to be? Is it going to be a PV or FV? No, because we're not making repeated payments. So it's either the compound interest formula or the natural growth formula. Which one is it? Compound interest. It says, highlight, compounded monthly. That tells you this is the formula that you are using. So it says, how long will it take? So I'm going to look for T. To triple an investment if the interest is 0.018 compounded monthly. So this part of my formula I have figured out. My interest rate is 1.8 monthly, so that N is how many times a year? That's monthly 12. T is my unknown. What am I going to do over here? What am I going to put in for A and P?
X for P and 3X for A.
Absolutely. And, Declan, if you don't want to use another variable, then you could simply say something like 10 and 30. You are exactly right. We need to start with something and end up with 3 times it. That's it. It doesn't matter, kids, if Reed goes down and deposits $1,000 in this account, and Ellie goes down and deposits $100,000 in that account, it's going to take them both exactly the same amount of time to triple. So, pick a number or use an X and then triple it over here. Now, here's why it doesn't matter. What's the first thing we're going to do to solve that? Divide. So the first thing you're going to do is divide by 10. So you're going to be left with 3 over here. I'm going to go ahead and type that in and see if by chance, oh yeah, I can do that. I don't ever want you rounding off, but if you can type in and not round off. George, I know that this is your first day back at school. It's what, are we the last period? Yeah, we're the last period of the day. Everybody's getting kind of exhausted, but we got a test coming up. We have to do well, okay? So I need everybody's trying to stay focused. I went ahead and made that a decimal, so it's 1.0015 to the 12t. If I can't make it a decimal, then I'm just gonna have to leave it. But luckily I can make it a decimal. Now, look where my variable is. How am I gonna solve? Gotta have to take the logarithm. Now I'm gonna LOG, you are free to LN. It doesn't make any difference, but nothing's gonna cancel in this problem, so there's no benefit to one or the other. So I'm a creature of habit, I log, so I'm gonna log. And I did that so that that 12t would come out in front. Remember, in a logarithmic expression, an exponent becomes a coefficient. Now, how am I going to get my answer? What am I going to have to do to get my answer? Divide by the 12 and by the log. And since there's two things I'm dividing by, I'm going to make sure I put them in parentheses. So log 3, close parentheses, divided by parentheses, 12 log 1.0015. Oh my goodness gracious. It's going to take 61.08 years to triple your money at this interest rate. Okay? To kind of help you understand that. If my parents had put $1 in the bank when I was born in this account, it would now be worth about $3, a little over $3. It's a long time. All right, number 7. Find the interest rate required to grow $1,234 into $2,345 in 10 years if interest is compounded quarterly. Okay, what do you think? Which formula? Unfortunately, the one I just erased, right? Compounded quarterly. So I want to end up with 2345, and I'm going to start with 1234, and I am compounding quarterly, and I'm doing it for 10 years. If I just make that exponent 40, is that okay with everybody? N times t, 4 times 10. Now this is crazy. I don't know if we've done one like this where we're solving for r. Are we going to use logarithms? No. No. How are we going to start though? We're going to start the same way. We'll start by dividing. So 2345 over 1234 equals 1 plus r over 4 to the 40th. Now remember, we're not rounding anything off, so be careful whatever you're doing. But here's our issue. We need to solve for r, but he's buried in a parentheses that's being raised to a power. We have to get rid of that power, right? If I could get rid of that power, I'll just subtract 1 and multiply by 4, and I've got it. How am I going to get rid of that power?
Do the 40th root of the
Deck runs on fire. I take the 40th root of both sides. That's exactly right. I'm going to take the 40th root of both sides. Now, I'm going to do that in a second. But the 40th root of that is going to equal 1 plus r over 4. okay? So let's type in our fraction. Actually, let's not. Let's not type in our fraction. Let's type 40, because we're doing a 40th root. Go to math. Go down to the option that says the xth root. Put a parentheses, if you don't already have one, and type in 2, 3, 4, 5 divided by 1, 2, 3, 4. If you got 1.016, you're right. Now, when we did this kind of thing before, I told you that I don't usually 40th root. Instead, I raise to the 1/40th power. So that's another option you have. If you don't want to use the xth root button, remember that a 40th root is a 1/40th power. So I now have a decimal. I'm going to leave it on my calculator, but for sake of talking about it, I now have a decimal over here. So to solve for r, I'll want a -1, right? And then I'll want to multiply by 4. So my interest rate, hopefully you got 0.0647 or 6.47%. Is that what you got? Okay, so that is kind of a wild problem. No logarithms though, because remember, we only use logarithms if the variable is up here. Otherwise, you gotta figure out how to solve it. Awesome. All right, what is the rate of growth for a strain of bacteria that grows from 789 to 4321 in 11 hours? Formula. PERT. Yep, we need the PERT now. This is the formula we use if it's a biology problem. Or if it says anything about continuous growth. All right, so we're going from 789 to 4321 in 11 hours. We gonna need logarithms? Yep. Not first though. What do we do first? Divide. So 4321 over 789 equals e to the 11r. Now what? ln both sides. Once you get that number divided, because then you're right up here against the e, so we're just going to have ln this fraction divided by 11. Boy, that's easy compared to the last one. ln 4321 divided by 789 divided by 11. Did you get 0.1546? So if this had been a money problem, and it wasn't, but that would be like you're growing at 15% per hour. Okay. Number 9. Oh, this is making sure you know your properties of logarithms. Okay, so let's see. We've got the log base x of 7 is 0.123, and the log base x of 2 is 0.012. Okay, so those are given to you. That's given information. And now you're going to find the log base x of the square root of 7x. Is the whole thing under the radical? Yeah. Now, I know I've said this to you, but I don't think I've made it a big, huge deal, and it probably needs to be a big, huge deal. Radicals do not live in logarithm land. okay? So when you have a radical problem, and we had one a while ago where it was a 43 to 49, we had to change that. Well, we had to change this. So this is the log base x of 7x to the 1/2. And the reason you want to do that is because you know what you are allowed to do with that exponent now. Where does that exponent end up?
In the front.
Out in front. So we have 1/2 log base x of 7x. Now, you might be thinking to yourself, I am clueless. I don't know what to do. But you do. This problem is a little bit, I mean, it looks different than others that we've done. But how do I split that up? If I have the logarithm, forget the 1/2 for a minute, if I have the logarithm of these two things multiplied, I can pull that apart. How does that come apart? Adding. So I have a 1/2, and then I'm going to have the log base x of 7 plus the log base x of x. What's the log base x of x? No, it's not x. It's 1. Yep, it's 1. So this is just 1. That's one of your properties when these numbers match. And we know that the log base x of 7 was given to us, so that's 0.123. So all I need to do is add those two numbers together, so 1.123, and divide by 2. So the answer is 0.5615. Okay? All right, let's see, we're ready for number 10. Consider this exponential that gives the number of ants present in a colony at time t. Oh, it's not an exponential, it's a logistic. What is the maximum population of ants? Kids, you should be able to look at the problem. Some of these are going to be hard, but not the first one. The maximum population of ants is 600. Because remember, in a logistic function, the numerator is your limit to growth. Maximum limit. How many ants are present initially? Yeah, what does that mean? Initially. That's like your initial value. You let x be 0 or t. Yeah, let t be 0. So remember, your initial value is always 0, comma. So we are to find y, for problem B, if t is 0. So 600 over 1 plus e, is that 2 minus t? 2 minus 0. So that's just going to be 600 over 1 plus e squared. Calculator. 600 divided by parentheses 1 plus second ln 2. Remember, to get e, you second ln. Looks like we have, if I round off, we're going to have about 72 ants. It's 71.52. If you said 71, I wouldn't argue with you. How many ants are present after 3 hours? Okay, go back to our equation, which I didn't write down. But how many ants would be present after 3 hours? What will I do to solve this? Plug in, I'll do exactly what I did, but I'm going to plug in 3. So it's 600 over 1 plus e to the 2 minus 3. So 600 over 1 plus e to the negative first.
Yeah.
Same calculation, 600 divided by parentheses, 1 plus second ln negative 1. And I got about 439 ants. You with me? And then D. When will there be 507 ants? What am I going to do there? When will there be 507 ants? That's going to come in for Y. So 507 equals 600 over 1 plus E to the 2 minus T. How do I solve that? Cross multiply or bring this over. So 507 plus 507 e to the 2 minus t equals 600. Minus 507, so 507 e to the 2 minus t equals 93. Divide by 507, so e to the 2 minus t equals 93 over 507. ln. So 2 minus t equals ln 93 over 507. Now just be careful here. It might be easier if you simply rearrange these two. So 2 minus ln 93 over 507 equals t. Add the t over here, make it positive t. Subtract this over. That might be easier for you. I don't care how you do it. Somehow you got to end up with the same answer I do, which is 3.7. Does it say hours? So when will there be 507 ants present? About 3.7 hours.
Good afternoon, Cathedral.
Okay.
First day
we
back
will
together.
finish
It's so great to see
the
you all
last
here
one
today.
next time.
Hope you got through it just fine. You'll find the sunshine.